Hello, welcome to my new video. Yet again, this is another transmitter video. It's a simple transmitter this. It's only a 2 transistor, so it's got an audio amplifier here. And this is the oscillator transistor. No output stage, no RF amplifier or buffer stage. So it's a very simple build. All the parts are very easy to get. I try to use the same parts where I could to save you money around for different values. But you know, the connector here for your battery is recovered from an old Sony battery, so it's been recycled. On the printed circuit board, that's the best part of this one. You can build this in your house within 20-30 minutes without any special parts. I get a lot of emails each week asking, can you build these boards without using any special equipment, like you know, fluoride chloride to etch the boards, laser printers, stuff like that. Well, there is a method of doing it, and in this video I'm going to show you how to. It's very simple, very effective. I ain't going to show you the other side of the board. You'll have to watch the video to see how I make this transmitter, but it works fine. Okay, shall we get on with building the circuit board first? Well, if you're wondering what on earth this is, well, this is what I'm going to be making the circuit board from. Looks like a mini skip. Well, it's a storage container. Quite a very thick plastic. It's going to be about 2.5–3 millimeters thick. That's going to be ideal really to make our board from. So what I'll do, I'll just cut this. I'll cut a square piece out of this. Quite tough to cut. Well, as you can see, this is not very easy to cut. It's quite a thick plastic. There we go. That we're going to make our circuit board from. Well, next I'm just going to cut out the outline of the board size and the drill holes. I can use this then to put round for the size of the board. Well, next I'm just going to mark out the board so I know where to cut the plastic. Okay, it's not brilliant, but it'll do. Let's get cutting. One side done. Well, here's the board after it's been cut out. What I'm going to do now is just go outside and quickly rub this on the floor to clean the edges up. And we'll do the drilling next. Okay, here's the end result. Not bad, is it? What we'll do now, we'll use the template we've got here for the drill holes. What I'll do, I'll take that down and we'll get drilling. So what you've got to do, line this up nice and carefully. Should get it about like that. Just tape that around with some sellotape. I'll do the other 3 sides. Okay, next stage is doing the drilling. So we've taped this on now, so it's on nice and firm. It's giving no weight. Just be careful doing your drilling. So just come off the centre of the holes on the template. Go right the way around. Okay, we're on our last one, number 43. That's it. Okay, there we go. All drilled out. Alright, what we'll do now, we'll put our positive and negative rail in. And we're going to put a link in as well, just underneath the tank circuit. Okay, what we're going to do next is install the positive and negative rail. I've got some solid core wire here, so that's single core. It's 0.6 millimeter. The core is, so I'm going to strip some of that off. Okay, first of all we're going to install our positive rail. This goes here on the circuit. Okay, you know where that goes now. So what I'm going to do is just feed this through the bottom. I'm just going to have it coming out slightly there, I'll lap that over. Once this circuit's complete we can trim these off because the components will hold everything together. Once it's all soldered together. Okay, there's our positive rail in. Right, we'll do our negative next. I know this is the most unusual way of doing a circuit board, but this is for people around the world who get many texts from a day who say they can't access chloride, or they haven't got a laser printer, so they can't make their own circuit boards using the transfer toner method. So this is one way of building a circuit board up very cheaply, very easily. Okay, should put the negative in next. Okay, we're just installing the negative rail. There we go, just pull that through nice and tight. There we go. Okay, the next one is this link. Now we're going to put this link in because there's a few components going to install around this area, so just makes the job a lot easier. So on the circuit, this is where this link goes. Alright, you see where that goes? So there we go. Well, this is the board complete. I hope that's focused. I apologise if it goes a bit dark, I haven't got my light. Left my light somewhere else. Yeah, there we go. That's our positive, negative. And our little link here. Well, that's the board done. What we'll do now is put it all together. Oh, here's our parts list. Not many parts, only 19 components. There's our made board, as you seen me make earlier. There's our Sony battery, and we're just going to strip this down and use the connector, so we can recycle that. Our transistors, they're 2N3904s, our 4-turn coil, our resistors, our caps, the antenna. Right, not too many parts. Should we build it? Okay, our first part is R1, which is a 47k resistor. We'll just pop that in. Now what I'll do, there you go, this will solder to the top of the positive, so I'll cut that there, solder that. I'll leave the other end because that will need to connect to the mic. Okay, this is where I'm going to solder this on the circuit. Okay. There you go. Okay, the other side I'll just trim for the moment. I won't be soldering that in yet. Alright, our next part is C1, which is the 100N. This takes the signal from the microphone and sends it to the base of the audio transistor. Right, we'll just pop that in. There you go. So what we'll do, we'll bend this connection round here because this is going to connect here on the circuit. Right, seen that. We'll just trim the other end. As you can see, I've soldered nothing in at the moment because what we'll do, we'll get the mic in, because then we'll have 3 connections just here, then we can solder. Then we've got the mic ground going this end. Okay, let's get our mic in. Now don't forget, these mics only go one way, so get the polarity right. So we'll pop our mic in. Just to insert that just there. Right, that's our mic in. So what we'll do now, we'll bend the positive of the mic. Yep. So we've got the 3 to solder here now. And we've got the other end out, which is the negative side. Okay, we'll solder the mic in now on the 100N, both sides. So just always use a bit of flux. It does help with soldering, especially with this type of circuit. There we go. Right, the next part we're going to install is the audio transistor. It's the 2N3904. Brilliant little transistor, it's a very common transistor. Very good for these sort of circuits. Right, pop that in there. There you go. What I'll do, I'll solder the negative side down here. I think I'll do that next. Okay, this is the emitter side of the transistor, this pin here. So what I'm going to do now, solder that to the negative side, the negative rail. There we go. Okay, we've soldered in the emitter side of the transistor now, the audio amplifier for the microphone. So the next one we've got to do now is this pin here. See here? Now this is the base of the transistor, so we need to feed the signal from the 100N, which is here. That's C1. So we need to feed that into the base. So what we'll do, we'll cross them two pins over there. So here's the one side of the C1. So the signal, the output will come from this end here, and that goes into the base of the audio transistor. So we'll just cut that. There you go. So we've got them two pins there connected now. Okay, next part is R3, the 10K. That goes in just here. What we'll do, we'll solder in the positive side, and I'll show you where the rest of it goes. So we'll turn it over. So that's our positive side up here, remember. So we'll just trim that. We're just going to solder in the positive side of the 10K R3. There you go. Right, next part is R2, which is the 1 meg resistor. Now this goes across the base and the collector side. Right, so we'll work out where it all goes in a minute, so we'll install it first. There you go. Okay, these are the two pins of the 1 meg I've just installed resistor, which is R2. So the one side I'll trim now, which goes to the base of the transistor, the audio transistor. So this is here. So I'll move that over there. So basically what we're doing with this, we're creating the circuit as we go along. So I'll tidy that up first. Okay, we're going to solder these together now. So this is where on the circuit I'm soldering this lot. Alright, so we'll get that soldered in now. So it might look all complicated, but it's not. It's quite simple. So now this is the 10K. Remember the 10K installed, we did the positive side. This is R3. So this will connect to the collector side of the transistor, which is this pin. So we'll bend that pin over, up facing towards the 10K. So that will connect to that. Right, there we go. Right, and the other connector, the other side of R2, the 1M, will connect to the same 3 pins, or to the same 2 pins. There we go. So what we'll do now, we'll solder that lot together. Job done. Next part is C2, second 100N cap. Install that in out. There you go. And that takes the output from the collector, from the amplifier stage, and sends that to the base of the second transistor, which is the oscillator transistor. Alright, we'll solder that in next. On the circuit, this is where this connection is. That's it. Okay, next part is R4, the second 48K resistor. So that goes in just out. What we'll do, we'll trim the top half, which is out, and we'll connect that to the positive rail. Okay, solder in the positive side. That's it. So we've done the positive side of R4. Now this will connect, the other side of the R4 will connect to the output side of C2, which is here on the circuit. Alright, so what we'll do, we'll just trim them, that one. This is the other side of C2. Join them together. Next part we're going to install is C3, the 1N. Just goes in and out. Right, the one side goes to the negative side, so I'll get that in first. Right, what I'll do now, solder in C3 on the negative side. So done. The other side of C3 will connect to the output of C2, which is here on the circuit. Just trim that, get that ready for soldering. Right, so solder them right in. That's all done. It's looking okay, isn't it? Second transistor now, which is the oscillator transistor. This is also a 2M3904. There you go. Okay, the first pin of the second transistor we'll solder in will be the base pin. So if we turn it over, you can see here, here's the middle of it, there's the base, so we'll bend that over and we're going to connect it to here on the circuit. Okay, so we'll solder in the base next. I mean, I could have connected all these together and soldered them in one go, but just so you can follow this circuit a bit better. There we go, soldered in. Okay, the last resistor now, which is R5, the 470 ohm. Now this controls the current going through the second transistor, the oscillator transistor. So this is a 470 ohm. If you haven't got one of these, you can use a 330, a 300 ohm. I wouldn't go much lower than that if you're using 9 volts. I mean, you can use 100R, but it will give the transmitter a bit more range, but the transistor will get a bit warm. So what we'll do, the one side goes to the negative side, so I'll get that in next. Well, let's get the negative side done. Soldering, that's brilliant, but it's hard to work around the light on the camcorder. So that's the one side of R5 done. The next side goes to the emitter side of the transistor. Okay, this is the emitter pin of the second transistor, so we'll bend that over because it's going to go towards the C5, the 10p, which goes across the base and the collector. Right, so that's there. So this R5 will also go to the same place, so we'll just put that there for the moment. On the collector side of the transistor, we'll just bend that pin over towards this link wire I put in earlier. Here we go. Okay, next one is C5. That's a 10pf that goes across the emitter and collector of the second transistor. So I'll pop that in there. That's installed. So as you know, it'll connect to this side here and this side. So I'll trim that up. Okay, what we're going to do now is solder on this side, the emitter side of the second transistor pin. Don't forget that connects to one side of the 10p PF and the other side of R5, which is a 470R. I'll show you on the circuit. This is where it is on the circuit. Okay, should we get that lot soldered in? Great. Right, next part we're going to install is the coil, 4-turn coil. This is formed around a 3mm drill bit. So I'll just pop that in now. Right, so we'll solder in this part next, which is the positive side of the coil. Alright, solder in the positive side of the coil. There you go. Right, the other side we'll just bend it round, so just touch this lot here, because we'll solder all this in one go. So that's the coil fitted. Okay, next part is the 33PF, which is C4. This makes up part of the tank circuit. Right, so as you know, if you've been looking at the circuit, one part will go, the one end will go across the positive coil, and the other side will go to the collector side of the second transistor. Okay, soldering on one side of the 33PF. That's it. Next, what we'll do, we'll just trim the other side. Don't forget, this is the collector side of the transistor, so we'll solder that up in a bit. Okay, what we'll do now is soldering all our connections now on the collector side of the transistor. That's great. Next is C6, is the output from the collector, which will send the signal then to the antenna. Now for maximum output, you can tap this off the collector, which is here on the circuit. But if you want this transmitter to have, decentish range, shorter range, but for the transmitter to be more stable, you can tap it off the emitter side. So anyway, we'll connect that to the collector over here, and that in there goes to the antenna. We'll cut them short. Okay, so as you can see, here's C6. That's the output. There's the R for the antenna. So that's where our antenna wire will come through, and we'll solder that here. This side here goes to the collector side. I should have actually put this in earlier and soldered it all together, but oh well, we'll do it now. C7 next. I think this is the last component. Right, that goes across a positive and negative rail. This keeps the circuit nice and tight. It helps the frequency stay stable once the battery starts to die off. That goes across there. We'll just trim them and get them soldered in. That's one side. Okay, that's all the parts installed. You might notice I've got another 2 holes here. This is going across the tank circuit. That's just in case if you've got a variable cap for tuning, install it there, so then you can tune the transmitter then. The way I'm going to tune it in now is just pull apart this coil, and that will adjust the frequency. So you close it in to lower the frequency and pull them apart to higher the frequency. So if you have got a trimmer, just drop it in there. If not, this circuit will work perfectly without it. So it just gives you the option. Not very hard to build, is it? A very easy circuit to put together. So what we'll do now, we'll make up a battery connector now with the old 9-volt battery. Okay, I'm just going to pull this battery apart now and get the connector out of it. I'll get some pliers on this. Okay, if you're going to attempt to open one of these up, please be careful because this metal is very sharp. There we go, there's our salvage connector. We can use that. Let's get the connectors in now, the power connectors. Last thing to do now is install the antenna. All done. Alright, to finish off, I'll just put a plastic tie around the antenna and the battery connectors so they don't drop off. It's a bit big, this tie, but that's all I've got at the moment. Complete. There we go. What we'll do, we'll test it next. Should work. Okay, shall we try it? Does it work? Well, let's clip our battery in. Fingers crossed. Oh, Houston, we have a problem. 217 megahertz. Oh, I don't think so. I think I know what's wrong there. Because I haven't used a variable trimmer in this circuit, on the tank circuit here, so I've got the coil and the 10pf, so what I'll need to do here, where an adjustable cap would go, I'll have to stick a 33pf in there, and that should sort out our frequency. Okay, so what we'll do, we'll stick this 33pf in. So one side goes to the positive and the other side goes to the collector side of the transistor. Okay, here's the collector side. This is where it goes on the circuit. And this is the positive side. Okay, well, we'll try it now for a second time. The 33pf's been installed, so that should be the tank circuit all correctly set up. You send this frequency counter on many more videos. A very handy tool, very cheap, only about £6–7. That's more like it. Bang on. That's all working fine now. Okay, we know the circuit's working now. To adjust the frequency, we're going to compress this coil, or widen the gaps between the coils to higher the frequency. So we're not going to get much. We might get 5 megahertz adjustment at most. If you use a variable cap, you get about 20. That's what we are now. Like 5.8. Alright, so if I just pull these coils apart, the frequency should go up. Yep. We're now 98.28. So that's how you adjust the frequency. Just by adjusting the gap in the coil. So that's quite stable frequency. Right, we'll give it a proper test now. Okay, before we test its audio, what we'll do, we'll test its power consumption and its RF power. So first of all, we'll test its current, what it's using. Shouldn't be using much, it's only a low power transmitter. There we go, just under 13 milliamp, which is great. It's not a lot of current. You get a few hours out of this 280 milliamp 9V battery. But this transmitter will also work on a 3V, so with 2 AIs it will last many days. That's not bad. Okay, next we'll test its RF power. A transmitter this size, it's only got a single transistor, it hasn't got an output stage, it isn't going to have a lot of power. You know, 3 to 6 milliwatts maybe. But even saying that, you know, you'll still get on a transmission range of anything from 200 foot using a handheld FM radio up to over 1500 foot maybe using a decent car FM radio. Anyway, let's see what this transmitter's got. Well, it's about what I thought, 4.35 milliwatts. That's okay, considering it's only using just under 13 milliamp current. That's not too bad. Okay, next we'll test its audio. Okay, we're upstairs now. We'll test the audio on it now. Here's my digital and FM radio. We'll just stick it on a digital channel. Not on any music playing, do I?
Deciding what to do with the extra second and another 10 seconds on this tweet. Isn't it always the way? And Angus says, is this extra second we will get called Fergie time?
Alright.
Now that's the leap minute we're going to get sometimes.
And now it's tuned in to the right channel.
First for breaking news and the best live sport. This is BBC 5 Live.
Right, so it's raining again, is it? UK for you?
So what we're going to do about the A&E crisis, how do we solve it? What do you think? 0500 909
Still got a bit of light on, still got a full signal.
And that's our top story on 5 Live this hour, as those A&E waiting times fall to their worst level for a decade. And Sport Rangers reject a takeover offer from American businessman Robert
Can't stay here too long, it's raining.
Is BBC 5 Live.
It's on the other side of the house.
I'm Rachel Bland. The Shadow Health Secretary, Andy Burnham, says there's now a crisis in the NHS in parts of the UK. A&E waiting time figures for England have fallen to their worst level since targets were introduced 10 years ago. 92.6% of people are being seen within 4 hours. The aim is 95%. Andy Burnham.
Right, I'm right on the other side now. Full signal. I think I've got the volume up slightly too high. On the radio, it's very sensitive, the microphones.
To the ward, the pressure is backing up through A&E, and ambulance services can't hand over patients at A&E. This is the root cause of what we're facing right now.
A number of hospitals in England have declared major incidents recently as pressure
bad,
on
is it?
A&E services
Very
grows.
simple build.
The Conservative MP Mark Pritchard will face no further action over rape claims.
Well, build it yourself.
The Metropolitan Police has dropped its investigation.
Doesn't need any special parts. And if you have any problems, just ask us in the comments. If I'm not too busy, I'll get back to you. Anyway, if you like this video, please give us a thumbs up. And if you haven't subscribed, please subscribe. I'll see you all soon. Testing, 1, 2, 3, testing. 1, 2, 1, 2, 3, testing. 1, 2, 3, testing.